right. So, in this section we shall really talk about value of information, but before we really take up the value of information, let us look at the sensitivity analysis problem which we had taken in our previous class. So, the problem that we have taken up is, let me very quickly repeat, is that we have a decision situation where there are two options, constructing a large plant and constructing a small plant. The expected value has come out to be higher in case of constructing a small plant. So, we wanted a sensitivity of this decision for different probability situations. So, what we do, supposing let P as the probability of a favorable market, and therefore, 1 by P would be the probability of an unfavorable market. So, let us do this problem. So, first of all, these are the two decisions: construct large plant, and the second one was construct a small plant. Right. So, we have again two states of nature, that is favorable and unfavorable. Right. So, supposing the probability is not uniform, I mean not unique, rather we say it is P and 1 minus P, and these are our payoffs, say 200, 100, actually 200,000 and 100,000, and here minus 180,000 and here minus 20,000. So, these are our payoff. So, you see what we have got here is that if you really look at the calculations, then what would be the expected value? The expected value would come out to be 200,000 P minus 180,000 into 1 minus P, because that is how is the expected value we compute. So, if we evaluate this, it will come out to be 200,000, that is 380,000 P minus 180,000, right. And similarly, for the second one, it will become 100,000 into P plus, basically minus, so that minus we taken out. So, 20,000 into 1 minus P, and it comes out to be 120,000 P minus 20,000, right. So, these are that what we get for the two, and obviously there is a third also, do nothing. For do nothing, these are 0. So, here it will be nothing but 0 into P plus 0 into 1 minus P equal to 0. So, nothing to do here. So, this is how the expected values could be calculated in terms of the favorable probability P. So, one is coming to 380,000 P minus 180,000, and the second case is coming to 120,000 P minus 20,000. So, let us look how they combine. So, you see what you can do, you can actually plot them these. So, we have plot here the EV large plant and EV small plant. Look at this particular plot. So, this side is expected value. So, if you look at this first one is 380,000 P minus 180,000. So, it starts with somewhere around minus 180,000, and this plot is because it has a larger slope, right, it has a larger slope and it is actually going up, that is called the EV large plant. On the other hand, the EV small plant is having only minus 20,000 to begin with, but it has a smaller slope, and those 2 points actually cut at a particular point, let us call it point 2. So, that is 0.615, right. So, what is the significance of this particular graph? You see what happens if the probability p equal to 0, right. So, you are expecting the small plant to be better, and with essentially only minus 20,000 will be its payoff, and it will break even when the probability is 0.167. So, at a 0.167 probability, the expected value for the small plant comes out to be 0, right, and similar thing is coming out for the large plant at a slightly higher probability. But at 0.615, the expected value for the large plant takes becomes bigger than the expected value of the small plant. So, what is you can do therefore? What you can do, you can divide the actually these into 2 zones, that if the probability is, let us write it down, if the probability is above 0.615, then large plant is preferable. If the probability is less than 0.615, then the small plant is preferable, right. So, that is the significance of this sensitivity analysis. Let us look at the summary of this once again. So, point 1, EV do nothing equal to EV small plant, if you put, then if we put 0, then we get P equal to 0.167. So, at 0.167 probability, it is better to construct a small plant rather than do nothing, and the point 2 is the EV small plant equal to EV large plant. If we equate, then we get P equal to 0.615, and then we get this particular decision matrix, that best alternative is do nothing if the P is less than 0.167, the construct a small plant if the probability is between 0.167 to 0.615, and construct a large plant if the probability is greater than 0.615. So, this is actually important because you see the P was basically, look at this thing, the P is basically the probability of a favorable market, right. So, when the favorable market probability is less than 0.167, you take one decision. When it is between 0.167 to 0.615, you construct a small plant, and when it is greater than 0.615, it is better to construct a large plant, right. Now, let us look at the concept which we initiated earlier, that is about the value of information. We have seen in our previous this thing that the under decision making under risk, we have an expected value and we also have an expected regret, and the expected value and expected regret, when you add, we actually get a constant value. So, this brings us to a concept of the expected value of perfect information, right. So, EVPI signifies the gain in expected return obtained from knowing with certainty the future state of nature, right. So, EVPI is the maximum amount a decision maker would pay for additional information. So, that we can call as the expected value of perfect information. Expected value of perfect information can be obtained by assuming that a consultant will be able to give perfect information about the true state of nature. and these EBPI will always equal to the minimum expected regret. So, we can, if we look at the calculations once again, we see this particular expected regret value which was 54 for redesign, the refurbish for 30 and do nothing for 88. So, actually if you look at it from another point of view, that assuming perfect information was available, when perfect information is available, then the person would have really gone for a decision like do nothing, decision like suppose it would have gone for do nothing, it would have gone, if there are no market changes, and the person could have gone for refurbish for a favorable market situation, right, and the person again would have got an unfavorable market situation, these do nothing for unfavorable market situation. In other words, if perfect information is available, the decision maker could have maximized their probabilities by appropriately taking a particular decision alternative based on what is the payoff at that particular situation. So, what would be our payoff under that situation? The payoff would have been, let us calculate, let me repeat once again that under the perfect information, a person would have gone for refurbish because that is where it gives a maximum payoff of 50, then would have gone for refurbish once again in case of favorable market, and would have gone for do nothing in case of the unfavorable market situation. So, in that case it would have got 50 into 0.4, 200 into 0.4 and minus 50 into 0.2, that is a total payoff of 90, and this 90 is can be actually called the what is known as the total amount that it would have got, the maybe you can call the payoff with perfect information. So, payoff when perfect information is available. So, that actually gives us another term that is known as the expected value of perfect information is coming to two things. One is the expected return of the expected value approach and expected return with perfect information, right. So, the ERPI minus the best expected return that we have got in the EV approach. So, that would have been the expected value of perfect information. So, coming back, so under this situation you see, let's look once again. So, in this case the ERPI, so this is our ERPI or expected return with perfect information, right. So, let me sum it up that ERPI is 90, right. Why? That is the expected return with perfect information. expected return with perfect information is 90. And the second one is the EREV. What is EREV? Expected return with EV or expected value approach. So, what is the best possible expected return with the expected value approach? So, in this case we have got the EREV equal to 30 equal to 60, I am sorry 60. So, 60 is the expected value that we have got with the best possible decision. That means, we have got an expected return is 60, but we could have got up to 90, right. So, 60 is what we have got, 90 is what we could have got. So, EVPI or expected value with perfect information, if perfect information is available, then we would have got a return of 90 minus 60, that is 30. So, an additional 30 we could have got if we would have got what is known as expected value with perfect information. Now, how perfect information can make a difference? Let us take the problem. In fact, let us look at another problem and try to compute this from the first principle, right. So, that would have really give us another exercise, and we could have do the entire calculation once again. Let us look at this particular problem. Let us look at this particular problem where we have these the states of nature and the different alternatives, and how these calculations are coming together. So, let us take up this problem once again and look at it from that point of view. So, first of all, we have construct a large plant, construct a small plant, and then do nothing. And we have the two states of nature, favorable market and unfavorable market. The probabilities are 0.5 and 0.5, and let us take the 200,000 is the payoff here, 100,000 is the payoff here, 0 minus 180,000 is the payoff here, minus 20,000 is the payoff here, and 0 is the payoff here. So, what would be the EREV? That is expected return with the expected value approach. For the expected return with the expected value approach, what is the return that we are expecting? How much we can get is basically 200,000 into 0.5 plus minus 180,000 into 0.5, and it comes to total around 10,000. So, 10,000 will be our EREV, but if we would have constructed a small plant, then we would have got 100,000 into 0.5 minus 20,000 into 0.5 and it would have been 40,000. So, this would have been our expected return with the expected value approach. So, this would have been, and obviously we would have constructed a small plant because that is giving us a better expected value. But the question comes that if we would have had perfect information, then if it would have been a favorable market, we would have constructed what is known as the large plant, because that would have given us better expected value. And if it would have been a unfavorable market, we would have constructed as we would have done do nothing, because that is giving us the better or the best possible payoff. So, under that situation we can actually calculate what is known as the ERPI, that is expected return with perfect information. What is the expected return with perfect information, right? Expected return with perfect information, that would have been something which will be dependent on both these values, and that would have been the 200,000. So, ERPI would have been 200,000 multiplied by 0.5 plus 0 multiplied by 0.5. Why? Because 200,000 is the best possible payoff when we construct a large plant if favorable market comes up. If we would have had perfect information, we would have gone for constructing a large plant and would have got a payoff of 200,000. Similarly, had it been an unfavorable market, we would have done nothing because perfect information is available and we would have got a payoff of 0. So, it comes out to be the ERPI value which would be around 100,000, and this ERPI value of 100,000 is independent of whether we make a perfect this decision or the other decision, and therefore, that is what would have been our ERPI 100,000, right. So, we have an ERPI of 100,000 and we would have an EREV of expected return of the EV approach is say 10,000, 40,000 and 0, and our decision would have been 40,000 because that is the highest. So, this actually gives us the calculation of what is known as EVPI, that is expected value with perfect information and that would be our ERPI, that is expected return with perfect information minus expected return with expected value. That means, it would be 100,000 minus 40,000 because that is the return that we have got, and that would be 60,000. This 60,000 is what is known as the expected value with perfect information, and this is essentially what is known as, can be called as value of information. You see, that is the focus of discussion of today's class, that the value of information really is 60,000. That means, if someone would have given us the perfect information, we could have paid that person the maximum of 60,000. Why maximum? Because beyond that, if we pay, then we would have made loss, because 40,000 is the payoff we have already got. We can reach up to 100,000 with perfect information, and if perfect information is available, we could have gone all the way up to 60,000, another additional thing. But question is different. Question is that is it really we can give these 60,000? Answer would have been very difficult really. Why? Because you see what is going to happen is, although we can theoretically give up to 60,000 because that is the value of information, but how much can we really depend on the exact information given by the person, the expert, and how much we can depend on that. That is where and very interesting thing really comes up. That is, when an expert gives an information, obviously again there is a doubt. The doubt in the sense that information may not be 100% correct. So that kind of analysis, we require what is known as a Bayesian analysis. We had to therefore construct a probability matrix and really think that how much of that information we can really depend upon, right, and based on which we can recalculate and we can come up with a different set of values. In fact, in the decision making literature, that is really called what is known as an experimentation. So if we go for an experimentation, how with that experimentation we can get a different sort of result, and how we can modify our decision structures, that is what we shall discuss in our consequent classes, right. So thank you very much, and we will continue this in our next.